Poor Jerry has been in an unfortunate accident with his kayak. The equation for the water leaking out of the kayak is given as a rate, and the removal of the water of the kayak is also given as a rate. So if we wanted to know what's the rate of the water leaking out after 2 minutes, we'll use our first equation. So the rate of the first equation, which is going to be a rate, so I'll just put a dash of 2 minutes, is going to be 5 minus 5 e to the minus 0.2 and multiply it by 2 minutes, which will give us a value of 1.65 liters per minute, and this is from using the calculator. Now the rate at which Jerry removes the water after 2 minutes is going to be 6 take away 6 e to the minus 0.1, and we'll multiply it by 2 minutes. And once again, using the calculator to work this out, we'll get 1.09 liters per minute. I should put minutes like this. So note that the rate at which the water is leaking is higher than the rate at which the water is being removed. Okay, so I'm a huge fan of visualizing these particular equations using a graph. And here the red one indicates the one that says that the water is leaking. And the blue one describes the water being removed by Jerry. The x-axis, of course, shows you the time in minutes. And, of course, the y-axis tells you the liters of water. And around 2 minutes, we calculated the water being leaking and the water being removed by Jerry. And in a way, from this graph, we can see that somewhere around 16 minutes, Jerry will win the situation, and the amount of water leaking and the amount of water being removed will be the same. So the area under the curve will determine the amount of water in the boat or the amount of water that has been removed. So if I wanted to find out how much water has been leaked into the boat between 0 and 3, I would need to look at this area up to 3 and find out what that area is. So I'll be using the function, the red function R1. So the integral from 0 to 3, this 3, of that function R1 dt is equal to the integral from 0 to 3 of 5 minus 5 e to the minus 0.2 t dt. And that's going to be 5t plus 25 e to the minus 0.2 t and 0 to 3. And we now substitute. First we've substituted the 3, and now we're going to substitute the 0. And that can be simplified to 15 plus 25 e to the minus 0.6 minus 0 and plus 25, because e to the 0 is equal to 1. Okay, so we go on to work this out. So it should give me 3.72 liters. So what does it mean? It means that 3.72 liters have leaked into the boat. And so how would you interpret 2 to 5 of R2 dash dt? Well, R2 is the water which is being bailed out by Jerry. And so this is a question of asking how much water has been removed after 2 minutes to 5 minutes. So this is a question of how much water has been removed by Jerry from 2 minutes to 5 minutes. So we're just looking at that blue area over here, up to 5, with an equation of 6 minus 6 e to the minus 0.1 t dt, all in brackets. Now to integrate that, it becomes 6t plus 6 over 0.1 e to the minus 0.1 t, which is the same thing as saying 60 plus 60 e to the minus 0.1 t from 2 to 5. So substituting first 5, and then we do 2, and working that out gives me a 30 plus 60 e to the minus 0.5 minus 12 minus 60 e to the minus 0.2. Plug it in into the calculator and should get 5.27 liters, which has been removed or bailed out from the kayak between 2 minutes and 5 minutes. And so a third question has been posed for us, and we need to interpret this particular equation. So we know that this means that we're looking at the water from 0 to 8. That is the amount of water from time is equal to 0 to time is equal to 8. So the amount of water in the kayak from the time it struck the rock and Jerry's been moving it would be up to 8. Is this area over here that we're looking for? So we need to calculate this area, which is R1, or take away R2. So to find that integral, we could take away the R2 from R1 and do the calculations here, or we could use straight away the integrated equation for R1 and take it and separately take it away from the integrated equation of which is here of R2. So I will just write 5t plus 25 e to the minus 0.2 t, but we are doing it from 0 to 8, and then we're going to take it away from the next one here, 6t plus 60 e to the minus 0.1 t, and also we are integrating it from time 0 to time 8. So I substituted all these numbers in, and really whichever way you do it, it's okay. I have chosen this way. I don't know whether it's any faster. I'll just continue. And I'll just finish this off giving you the answer. So there is 5.89 liters, 8 minutes after striking the rock. And so we would use this expression over here to find out the liters of water in the kayak after 9 minutes, 10 minutes after striking the rock, as long as you know that you change these numbers here from 0 to 9 or 0 to 10. Well, I hope this has been useful and informative. And if you did find it useful, then please subscribe to my channel and like.